Africa is currently experiencing a remarkable transformation that is reshaping the continent in profound ways. Beneath East Africa, the Earth's crust is undergoing a significant change, as the Somali and Nubian tectonic plates are slowly pulling apart. This process is creating a rift that is expanding at a rate that may seem imperceptible but is crucial for the future of the region. As this rift widens, it is paving the way for the formation of a new ocean, which could dramatically alter the geography of Africa. In this discussion, we will explore the details of this geological phenomenon and consider the implications for the continent and its inhabitants. The 2005 Debarhu eruption was a pivotal event that brought global attention to the seismic activity in East Africa. In September of that year, the Debarhu area in Ethiopia experienced an extraordinary series of earthquakes, with over 130 tremors recorded in just 1 week. These were not minor quakes, they were powerful signals of the geological changes occurring beneath the surface. The local communities were understandably alarmed, as the ground seemed to become unstable overnight. Each earthquake was a release of energy, indicating that the tectonic plates were moving apart and that magma was rising to fill the gaps. On September 26, 2005, the Debarhu volcano erupted, pushing magma to the surface with significant force. While the eruption was not classified as explosive on the global scale, its geological significance was immense. The eruption created massive fissures in the ground, visible cracks that split the earth and forced approximately 6,300 people to evacuate their homes. The displacement of families and the destruction of livestock led to a humanitarian crisis, highlighting the vulnerability of communities living in the Afar depression. Despite the suffering, the eruption provided scientists with a unique opportunity to study the dynamics of tectonic activity in real time. In the aftermath of the Debarhu eruption, 37 miles of fissures opened up across the landscape, revealing the intense geological activity occurring beneath the surface. These fissures were not just superficial, they extended deep into the earth, showcasing the molten rock and thermal activity that were driving the rifting process. The displacement of the ground was astonishing, with sections moving several meters in just a few days. For scientists, this was a vivid demonstration of plate tectonics in action, as the Somali and Nubian plates, previously thought to be locked in place, began to tear apart under immense stress. The Debarhu eruption marked a significant turning point in our understanding of the East African rift. It demonstrated that the rifting process was not merely theoretical but a tangible reality. The magma rising from below acted as a catalyst, pushing the plates further apart and creating pathways for new geological formations. This event provided a rare opportunity for researchers to observe rifting on a human timescale, allowing them to document and analyze each step of the process with unprecedented detail. The East African rift itself is one of the most striking geological features on Earth, stretching approximately 3,000 kilometers from the Afar Depression in Ethiopia down through Kenya, Tanzania, and into Mozambique. This rift marks the boundary between the Somali plate and the Nubian plate, which are actively moving apart. Unlike other tectonic boundaries, the East African rift is dynamic and evolving, with the potential to create entirely new geological structures, such as valleys and coastlines. The activity in the East African rift is primarily driven by magma. Below the Earth's surface, magma rises from the mantle, creating pressure that pushes the Somali and Nubian plates apart. As these plates drift away from one another, the crust in the rift zone becomes thinner and more fragile, leading to the formation of fissures and fault lines. This process is a continuous cycle of destruction and renewal, where older crust is broken apart while new crust is formed. Gravity also plays a crucial role in the rifting process. As the rift expands, large sections of the Earth's crust sink under their own weight, creating dramatic escarpments and deep valleys. These valleys often fill with water, leading to the formation of iconic lakes like Lake Tanganyika and Lake Malawi, which trace the rift's trajectory. Over time, the forces pulling the Somali and Nubian plates apart will widen the rift to the point where water begins to flood the area, likely from the Red Sea and Indian Ocean. This will ultimately lead to the formation of a new ocean basin. The creation of a new ocean will have profound implications for the climate, ecosystems, and biodiversity of the region. Coastal areas will emerge where none previously existed, creating new habitats for marine life. However, this transformation will also pose significant challenges for human populations, particularly those reliant on agriculture and livestock. The flooding caused by ocean encroachment could displace thousands of people, while volcanic activity associated with the rift may intensify, threatening nearby communities. The East African Rift serves as a vivid example of how tectonic forces are reshaping our world. The ongoing changes in this region are part of a larger geological narrative, one that hinges on the unique characteristics of the Afar Depression, the epicenter of rifting activity. The dynamics of the rift are driven by the slow but relentless movement of the Earth's tectonic plates. The Nubian plate and the Somali plate are pulling away from each other at a rate of up to 2 inches per year. While this may seem slow on human timescales, it accumulates over millions of years, resulting in significant structural changes to the Earth's crust. The East African Rift is essentially a nascent version of what occurs along the world's mid-ocean ridges, like the Mid-Atlantic Ridge. As the plates diverge, magma wells up from the mantle to fill the void, creating new crust. This cyclical process will eventually lead to the formation of a full-fledged ocean basin. The mechanism is both simple and profound. As magma pushes upward, it weakens the lithosphere, causing it to fracture and thin. These fractures develop into fault lines and fissures, creating steep valleys in the escarpments. The geological processes driving the East African Rift are interconnected in profound ways. Plate divergence sets the stage, but it is the combination of magma upwelling, seismic activity, and crustal deformation that turns this rift into an active zone of change. The rift serves as a powerful demonstration of the delicate interplay between tectonic forces and surface processes, creating both challenges and opportunities for the region's ecosystems and communities. The formation of a new ocean in the East African Rift is a step-by-step process that transforms landlocked terrain into a vast body of water. This transformation unfolds in 3 distinct stages. First, the rift will evolve into a valley, marked by the formation of fault lines and fissures as tectonic plates diverge. Magma will rise through the thinning crust, creating volcanic activity and earthquakes that reshape the landscape. Over time, these processes will widen and deepen the rift valley, forming elongated depressions bounded by steep cliffs. Next, as the rift deepens, parts of it may dip below sea level. Water from adjacent oceans, like the Red Sea or Indian Ocean, will begin to seep in, forming isolated gulfs or narrow waterways. This stage is already exemplified by regions in the Afar Depression, which are below sea level and show early signs of water intrusion. Finally, over millions of years, continued divergence will widen the gulf into an expansive ocean basin. Magma will continuously rise to form new seafloor, and tectonic activity will keep the boundary active, further expanding the ocean. Scientists estimate that a fully formed ocean will emerge in roughly 5 to 10 million years. Current rifting rates, approximately 2 inches per year, drive this timeline, although geological disruptions could accelerate or delay the progression. The East African Rift provides a rare chance to witness the early stages of oceanic creation, and the projected timeline offers a glimpse into the future of the region. The impact of this transformation on ecosystems will be significant. Major geological changes often lead to profound ecological consequences. As land fragments and rifts evolve into oceans, ecosystems are reshaped, and biodiversity often flourishes. The influx of seawater into rift zones will create unique habitats, fostering diverse marine ecosystems. As rift valleys and eventual oceans form, climatic conditions will shift, impacting flora, fauna, and human activity in the region. The East African Rift holds the potential to drive biodiversity as ecosystems adapt through its gradual transformation. Geological events like rifting have far-reaching impacts on climate systems. The formation of a new ocean in East Africa could mirror changes seen in previous epochs, such as the rise of the Isthmus of Panama, which significantly influenced global climate. As East Africa's new ocean develops, shifting sea and wind currents may alter the region's climate, leading to changes in rainfall and weather patterns. Additionally, the rich mineral resources found in the region provide significant economic opportunities. The East African Rift is home to valuable minerals like gold, copper, and salt, and geothermal fields are being tapped as part of a growing industry. As geothermal power plants increase in number, they could provide clean, renewable energy to the local population and beyond. The people living in the immediate vicinity of the East African Rift have developed remarkable strategies to survive and adapt to ongoing geological changes. In the Afar region, communities have learned to harness geothermal energy from volcanic steam vents, creating systems for water purification and collection. This innovative approach allows them to thrive in an otherwise arid environment. Subscribe to our channel and thanks for watching.